Hello and welcome to Mossy Maths. Today we're going to be going through my second lesson on differentiation, and we're going to be looking at how we can apply differentiation to finding the equations of normals and tangents to functions. So the first question we have is find the equation of the tangent to the curve y equals x squared when x is minus 1. So I've done a diagram here of a random function. It doesn't apply to this question, but I'm just trying to show you what a tangent is. So if you're unaware what a tangent is, it's a line that touches a curve at exactly one point. So as you can see, this line here touches this parabola at exactly this point. So that's all a tangent is. And the gradient of a tangent will be equal to the gradient of the curve at that point. So, to start with, the first thing we do is find out the y coordinate when x is minus 1. So the first thing to do would be to substitute in x is minus 1 into the original function. So y would be minus 1 squared, so y is 1. So we can say with confidence that when x is minus 1, y is 1. And that's a starting point, okay? So the first thing we know is that when x is minus 1, y is 1. So the next thing to do is to differentiate the function. Hopefully you're familiar with how to do this now, having watched my previous video. So with y equals x squared, we just get 2x as our first derivative. Now looking at that, we can see that the next thing we're going to have to do is substitute in this value of x again, but this time into this function. So if we substitute minus 1 into 2x, we get minus 1 times 2, which is minus 2. This is our gradient. So what we've just done is found the gradient of the line at that point. Okay, so that's the gradient. So what we do now is we substitute in the values we've calculated into the following equation. Y minus y1 equals m multiplied by x minus x1, all in brackets, okay? So, our y1, if you're unfamiliar with how to do this, would be the value of y we calculated by substituting in our x value from the question into the original function, okay? So our y1 is 1. So y minus 1 equals, m is our gradient. Our gradient we calculated as minus 2. So y minus 1 equals minus 2, open brackets, x minus. Now x1 is the value of x given to us in the question, which is minus 1. Now try not to get muddled up with the double negative there, because that could confuse a lot of people when they're in an exam situation. So remember that's going to be a positive inside the brackets, okay? So simplifying this, we get y minus 1 equals, so minus 2 multiplied by x minus 2x. Now this is a positive 1 multiplied by a negative 2, so we're going to get minus 2. So, the next thing to do, we'll get this in the form y equals. In the exam you might be told to put this equation in a different form, however, mostly you'll be told to make it in the form y equals. So if we're going to put y on one side, we need to move the minus 1 across. So moving the negative 1 across, we get minus 2x, then minus 2 plus 1 will give us minus 1. So that, guys, is the equation of our tangent. That is all we're doing. So the first thing we did, substituting the x value from the question into the equation given to get the y value, differentiate the function, find the gradient, and then substitute what we know into that equation. Okay? So that's that. The second question we have is concerned with finding the normal. Find the equation of the normal to y equals x cubed at the point 2, 8. Now, a normal is a perpendicular to a tangent. So if we see here, the tangent is there, and the normal is this line coming off the tangent. The normal is perpendicular to the tangent, so it's at 90 degrees to it, okay? So, if we look back at the last question, the first thing we did was substitute in our x value to find our y value. However, here we've already told our first y value is 8. If you want to check that, you can substitute 2 into this equation if you want. Substituting 2 into y equals x cubed, we get y is 2 cubed, so y is 8. Right, So the first thing we do now is differentiate this equation. That becomes 3x squared. Okay, then we substituted our x value into this. 2 squared is 4, multiplied by 3 is 12. Now this will be our gradient if we were finding the tangent. However, we're finding the perpendicular to the tangent. So we have to remember that what we've got to do is find what we call the negative reciprocal of this value. All this means is a negative of the inverse of this value. So what we're doing is simply minus 1 over 12. Okay? That is our negative reciprocal, and therefore this is the gradient of the normal to this. And now it's just the same as the previous question. We substitute in the values we've calculated into this equation. Right. So doing that we get y minus y1 is 8 equals m minus a 12th. Open brackets, x minus 2. Now actually some exam boards will allow you to leave your answer in this form. However, to be on the safe side, I'd always expand this and simplify it to get y equals. In this case, we're clearly not going to get y equals on its own. We're going to get something something higher than that. So we're going to get y minus 8 equals, expanding these brackets, minus a 12th x. Minus 2 times minus a 12th gives us positive 2 over 12. We can simplify that, but I'm going to leave it in this form for now. So, with y minus 8, what we could do here, and I think would be the best option, is to multiply this whole thing by 12 to get rid of this fraction. So let's multiply this whole thing by 12. So we're going to get y times 12, that's 12y. Minus 12 times 8, that's 96. Minus x plus 2. Okay, so now we can see where this is going. All we need to do now is move this across and we're going to get it in the form 12y equals 2 plus 96 gives us 98. And that's the answer, guys, okay? In my opinion, it's better to leave it in this form. However, you can, if you want, leave it in that form. Remember, never simplify it to y equals, because that will actually overcomplicate it and give you fractions which you don't want. So you want it in this form with positive integers. Okay? So, thanks a lot, guys, for watching the video. If you have any questions, please write a comment below. And if you haven't already, please subscribe to my channel. Thank you very much.